In this demonstration, we'll take a look at how to use the ping command to verify connectivity with other devices on the network. So I've already connected to my Juniper device here, and I'm in operational mode, which does have a ping command available to it. And if you use ping space question mark, you'll get a list of parameters that are supported by the ping command. A few of the parameters that I want to make a note of is the first parameter is you can give the host name or the host IP address of the device that you want to ping. But also we have parameters like count, where you can specify how many ping messages to send out. You can specify as well whether you want to use the IP version 4 protocol or the IP version 6 protocol by using iNet or iNet6. You can specify the source interface that you want to use for those ping messages. You can also specify the interval for those ping requests. So what this is used to do is, instead of sending out ping messages one after the other, you could specify to delay each message by 15 seconds, 30 seconds, or whatever that interval might be that you want to use. We can also do things like rapid ping if we wanted to, where it sends out, a bunch of ping requests out very quickly. One of my favorite is the record route option, which displays the pathway that the packet took. And then we can also do things like use the source parameter to specify the source address of those ping messages. You can also control the size of the packets themselves with the size parameter, and also control that time to live value. So I'm just going to take a look at a couple examples of using ping. First thing is I just want to ping 11.0.0.1. Now I'm on the 13 network right now, so this should be passing through the 12 router to get to the 11 network. But I do want you to notice that when I do a ping space and the IP address, that the ping messages are sent out as ICMP messages. We can see there the sequence number. Let me control C this just to stop the screen. So you can see that the packets are 64 bytes, and we can also see the ICMP messages. So we get sequence 0, sequence 1. So each one has a sequence number assigned to it. The time to live value is there, and then also the response time is displayed as well in milliseconds. Now, a couple things I want you to notice is that I had to abort this. So by default, the ping command will send out one ping message after another, and it'll keep going, right? You can see down below here, after I aborted it, it gives me a summary. It says, okay, we sent out 13 packets. 13 packets were received, so I did get 13 replies, so that's 0% packet loss, so 100% response rate. Now, if you don't want to ping kind of continuously and have messages going constantly, what you could do is you could use the count parameter. So I can ping 11.0.0.1, and I'm going to do a count 3, which means send out 3 ping messages. And I want you to notice that very quickly. Notice that it stopped automatically. I didn't have to abort the actual ping command to stop it. So that's very useful. Another example of a parameter that's useful is I'll combine it with my count 3. So I can do a count 3. If you wanted to, you could force the protocol that's being used. So if you do have IP version 4 and IP version 6 loaded on the device, then you may have to force which protocol you want to use. So if I put iNet at the end as a parameter, that means that I want to use IP version 4 as the protocol to do my ping. Now, if you have IP version 6 running as well, then maybe you want to use IP version 6. So actually, I don't have IP version 6 loaded on this device, so let me do test.count3 iNet 6, right, would be the command. But what's important is I don't have IP version 6 configured on any of the interfaces, right? So I can't use that command. But that's how I can force it to use IP version 6 if I wanted to. Another example of a command that I want to show is I can ping 11.0.0.1 and specify the count of 3, let's say. I'll use IP version 4, so I'll put iNet there. which I don't really need in this example, but I'll put it there just for the sport of it. And then what I'm going to do here is I'm going to put interval 15 for delay each ping message by 15 seconds. So watch this. When I hit enter, the first ping has been sent out. I got my first reply, but notice that I'm not getting the second reply right away because I've delayed the next ping by 15 seconds. So any time here, within the next few seconds, we should see another reply come in. There it is there. So then again, it'll wait 15 seconds before sending out the next ping. So this could be very useful when you're troubleshooting maybe a problem with interface or something like that, and you want to send out ping messages continuously, so without doing the count, but you don't want them going out kind of one after the other. What you could do is delay them with the interval parameter, and maybe every 30 seconds or something like that, or 60 seconds. And when you do that, the benefit is as you're fixing the problem, whatever that connectivity problem is, you're keeping an eye on your ping replies for those next messages being sent out. So very useful. Now the last example I want to show here is I'm going to ping 11.0.0.1. I'm going to do a count of 3 ping messages, and I'm going to use the record route, which will display the pathway that the packet takes. So when I take a look at this, so there's my command, count 3 record route, we can see that we're pinging 11.0.0.1, 64 bytes from 11.0.0.1. It's ICMP sequence 0. Notice that we've got 11.0.0.1 over to 12.0.0.2, which is kind of the router that I'm passing through. And then for our next 2 ping messages, they pass through the same route, right? So they don't show the route for those ping messages. So that's a very useful command just to kind of see the pathway that your traffic is taking. So in this demonstration, we showed you the ping command in Junos OS.